Okay, some problems from section 9.1, and these are very similar to the exploration. We did in class, exploration, probably number 1, over on page 477. And some of exploration 2, similar to these. So the first one, and again the directions were, find a power series to represent the given function and identify its interval of convergence. When writing the power series, include a formula for the nth term. So 1 over 1 plus 3x, so I can write this as 1 over 1 minus negative 3x, so I can see that this is going to be a geometric series form. A1 is 1, and then r is negative 3x. So that's my ratio. And I can start with, I can write the general formula like this, negative 3x to the n. So when n is 0, I've got 1, then negative 3x plus 9x squared minus 27x, and this kind of conforms to this a1 being 1, or a being 1, and r being negative 3x. And then if you look at this, this is just going to be negative 3x to the n. So there's your general term. So this converges when r is, the absolute value of r is less than 1. The minus sign comes out, that won't make any difference because the absolute value of negative 1 is 1. So we just have 3x in between negative 1 and 1 and divide by 3. So we get x is between negative 1/3 and 1/3. So that's your interval of convergence. Okay. Number 55. X over 1 minus 2x. So we could say a sub 1 is the x and r equals 2x. Just keep multiplying it by 2x, and we can design it like that. Or we could take 1 over 1 minus 2x and multiply it by x. Either way, we get the same thing. So this is my first term, and this is my common ratio. This is my r, 2x. So x times 2x is 2x squared, times 2x is 4x to the third, times 2x is x to the fourth, etc. And this is my general term. You can see that if this is n is 1 and this is 2, because we have to use n for 1 because we're going to have an x, the first value. Then if n is 1, this is 2. Okay, this is going to be 2, 4, 8. This ends up being 2 to the n minus 1. N minus 1 if this is 1, so I should probably write the n's in there so you can see that a little bit easier. So we would have 2 to the n minus 1, so that would be 2 to the 0. That would give me my x term. All right, and then 2, when n is 2, n minus 1 is 1, so I have my 2. And then when n is 3, that's going to give me my 4. And when n is 4, that's going to give me 2 cubed, which is 8, so that's going to work out. So you can see that's your nth term, and this is our summation. So our ratio is 2x. R is 2x. So the interval of convergence will be when the absolute value of 2x is less than 1, or 2x is between negative 1 and 1, so divide by 2, and we get negative 1/2 to 1/2, so that's the interval of convergence. Okay, and there's the series. Okay, 56. Well, my a sub 1 is 3, and my r is x cubed, so 3, and keep multiplying by x cubed. All right, and again, this is n. Then that should work out if we check this out. If we have when n is 0, this is going to be just 0 or 1, so times 3. There's your 3. When n is 1, we've got that. When n is 2, we've got 6. So that'll generate that. And then again, this is my ratio, so it's going to converge for the cube root of r is less than 1, and the absolute value of that's going to be less than 1. And we can reverse the signs even if it's negative, so it still comes out between negative 1 and 1, so x will be between negative 1 and 1, so that's your interval of convergence. And don't worry about the, when you take the absolute value, that'll take care of any negative sign, so that's going to work out. Okay? And then number 57. 1 plus x minus 4, so we use negative x minus 4. So a sub 1 will be 1, and then r will be negative x minus 4. So the series will look like this. 1, and then negative, so we just keep multiplying by this, so I'll multiply by negative x minus 4, and then positive, that becomes positive x minus 4 squared, etc. And my general term would be negative 1 to the n. That's going to generate the opposite signs, and so this is going to go from 0. So this is n equals 0, 1, 2, 3. You can see the 3, and then this is out to the n. So the n matches the exponent. Okay, so again, we're using, a geometric series. Just try to figure out the nth term is kind of fun to do that. Just watch the alternating signs and then try to make sure the n's match up. And we're going to go from 0 to infinity. My index starts at 0 to infinity of negative 1 to the n, x minus 4 to the n. And that's going to converge for this. Negative, the absolute value of negative x minus 4 is less than 1, which is just x minus, absolute value of x minus 4 is less than 1, or x minus 4 is between negative 1 and 1, and then if I add 4, I get 3 and 5, so there's your interval convergence. Okay? Hope that all makes sense. So that's 57, or 54 through 57.